Okay, question one. If f of x equals this, then ask to find its inverse. So setting this up is easy. You just, rewrite it e to the 3 plus square root of x, and then just replace all the y's with x's and all the x's with y's. So this y becomes an x, this x becomes a y, and then you just do algebra, multiply, add, whatever, to get this y all by itself, and then what's remaining will be the inverse. So let's go ahead and do that. I think to start we do an ln of both sides. Oh, that's a crappy n, looks like an h. Do the ln of both sides, that would end up getting rid of this ln e, and you're just left with this top part. So ln x equals 3 plus square root y. Okay, we subtract 3 from both sides. So ln x minus 3 equals square root y. And then we just square both sides. So power of 2. So y equals ln x minus 3 all squared. There we go, e, that's the answer. All right, number 2. The domain of this function is what? So domain problem, we just have to figure out, we have to remember which uh, actions we can perform will impose a domain on our function. Looks like there's two here. One is this log, this ln. Remember, when you do a log of a number, it must be greater than 0. You can't do a log of a negative number. You can't do a log of 0. It's got to be positive. So that's one that we have to account for. The other is just the square root. So whenever you do a square root, it can't be negative. So greater than or equal to 0. So I'll keep those in mind while we parse through this. I'm going to start with the ln, the log. So remember, whatever's inside the log must be greater than 0. So we'll set that up. So 2 minus square root x is greater than 0. And then we just have to get x by itself. So minus 2 on both sides, that's negative x is greater than negative 2. And then flip the signs, so that's square root x. Oh, okay, this is important. So since we're dealing with inequalities, we have to keep in mind that if you ever multiply by a negative number or divide by a negative number, you have to flip the inequality. So that becomes a less than, since we just multiplied both sides by a negative one. So now it's square root of x is less than 2. And now we just square both sides. So x is less than plus and minus 4. And we're just going to consolidate this to just positive 4, not plus and minus 4, because when you think about it, let's have a number line. This is 4, this is negative 4. If x is less than negative 4 and x is less than 4, so let's draw this out. X is less than negative 4. That's this. So that's at negative 4 and goes left. X is less than positive 4 is this, which includes the entire domain of x is less than negative 4. So we're just going to keep it as x is less than 4 here. So I'll put it off to the side while I erase this for more work. X is less than 4. Make a box preemptively. Okay, so now, oh, and then a second restriction is easy. We don't have to do any algebra. It's just square root of x, and x must be greater than or equal to 0. So that's our two restrictions on this function. We just put it in the form that it wants, which is d. So it is greater than or equal to 0, and it's less than 4. That's exactly what we said over here. So that's that. All the others are just, slightly wrong, uh, revised, errored versions of D. Like A uh, starts at 0, goes off into infinity. That's not true. It ends at 4, remember? B I don't know how they got it. Starts at 4. Oh, they probably did. They probably forgot to flip the inequality. That's probably how they got that. Uh, C ends at root 2. I don't know. E, probably the same thing as B. They forgot to flip the inequality, so that one's wrong too. Answer is D here. The domain is from 0 inclusive to 4 exclusive. That's the fancy way of saying that. All right, number 3, let f of x be this function. Find the difference quotient of this kind of manual derivative that you've seen before. Okay, I have no idea what it means by the difference quotient, but I just did the work. All it wants you to do is simplify this. So you're given this, and you're given what f of x is, which is, that. So just plug in values and simplify it, and then the answer will be one of these. So uh, let's do that. So f of 2 plus h, plug in here, so that's x, no, not x, we're plugging into x. That's 2 plus h squared minus 2 plus h. So that's the f of 2 plus h, and then minus f of 2, which is 2 squared minus 2 all over h. I'm gonna leave that out for now because it's just gonna be the same every time. Well, remember to divide by h at the end. So then we go ahead and simplify this. So first part is 4 plus 4h plus h squared minus 2 minus h minus 2 squared, which is so minus 4 minus 2. Okay, so then this becomes h squared plus 4h minus h, which is plus 3h, plus 4 minus 2 is plus 2. Oh, that's r out. And then minus 4 minus 2, which is minus 2. Okay, so these cancel out too. So we're just left with h squared plus 3h. Remember, we're dividing all of this by an h. I just haven't been writing it this whole time for redundancy, so that becomes h plus 3. Boom. C's our answer. All right, question 4. Find a value for c that makes this piecewise function continuous for all x values. So, okay, so let's just understand what this is, what this function is. So specifically at the x value of 9, let's graph this out. Specifically at x equals 9, the function equals 6. Anywhere else, it's defined by this function. So who knows what it looks like? Maybe it's like whatever. We need to find a value for c where this function hits that line, basically. Um, But we have a small problem though, because if we just straight up plug in x equals 9 into the function, we end up having a problem because this denominator would end up equaling 0. And when the denominator equals 0, that's not very fun. But we can use that to our advantage actually, because why is my pen not working? There we go. When the denominator equals 0, the only way for a limit to basically exist at that point and for it to still be like, continuous is if the numerator is also 0. Why? Goddamn pen. Come on, there we go. The only way for the limit to exist here and for the function to still be continuous is if the numerator is also 0. So what we can do is set the top here equal to 0. So x plus c equals 0. And actually, instead of x, we'll do 9 at that point. So what the hell is going on? 9 plus c equals 0. So c equals negative 9. I'm writing this with my finger because my pen just crapped out. C equals negative 9. That's our answer. Well, what we could do, I mean, that was very quick. And that is indeed the right answer. What you could do is actually go and verify this. So you could plug in negative 9 for c and then evaluate the limit and see if it all works out. So let's actually go ahead and do that. Make sure we're doing this right. So x plus negative 9, x minus 9 over root x minus 3. Um, and then we just sort of have to simplify this. So when we plug in x equals 9, it'll work out. So what we can do here is multiply by root x plus 3. That I forget like the name of what we're doing here, but you just the top and the bottom, uh, like you have some kind of polynomial with a square root in it, so you just multiply it by another function where both the top and the bottom are the same thing but with the sign flipped, and this just equals 1, so we're not changing the function at all. So the top will keep as the same, x minus 9 times square root of x plus 3. But the bottom, this actually becomes, so like, if you have something like x squared minus 9, that becomes x plus 3, x minus 3, something like that. So we're just doing it sort of in reverse. So this becomes, you'll see it's x minus 9. And then we see those cancel out. We're left with square root of x plus 3. And if we plug in uh, 9 for this, we get square root of 9 plus 3, which is 6. And that is, yeah, that's exactly what we want. It's 6, which is what x was defined at in the original function. So we know we did that right. C must equal negative 9 for this function to be continuous. All right, question 5. You've got this function, and it's asking you some limits about it. Looks like in each one, it's the limit as x approaches 0 from the left, and limit as x approaches negative infinity. All right, so let's start with 0 from the left. So if we just plug in a 0 for all of these, we end up getting 0 plus 1 over 0 plus, we end up getting 1 over 0, which is just infinity. So found our limit, right? It's got to be, one of these. Well, hold on, because a limit approaches infinity, that can sometimes mean a function where it goes like this. So it could either be infinity or negative infinity. So we need to clarify that, see which one it is. And that one we can just kind of cheat it a little bit. We can just make a number line, plug in some values for x that are right around 0, and then go from there. So we have 0, which we saw as undefined. If that's the limit we're trying to find, let's do 1 and negative 1. And then we're just going to sort of plug in values that are like, in here and in here. And then, one side will be positive, the other side will be negative, and then whichever's on the left side here, we'll do that. It'll be either negative or positive. So let's do that. I think positive and negative a half would work well. 1/2 there, negative 1/2 here. And we just plug it into the original function. So let's see, 1/2 cubed plus 1 over 1/2 squared plus a half. And you don't actually have to evaluate the entire thing. Just try to figure out if it's positive or negative. So that looks like the top will be positive and the bottom will be also positive. So this will end up being a positive number. So we know that on the right side of the function, this will be positive, at least for a little while, at least surrounding the 0. And then for the left side, let's do negative. So let's plug in negative in our function. We can do negative a half cubed plus 1 over negative a half squared plus or minus a half. Okay, and then looks like this would be 1 minus an eighth, which is still positive. And then this would be a fourth minus a half, which ends up being negative. So, a positive number divided by a negative number is still negative. So we know that surrounding the 0 on the left is negative numbers. And since we are approaching the limit from the left side, from the negative side, we know that it will be negative. So the only the answer choices that have the negative infinity will be correct. So not B, not C. And then, so that's our first limit. It's negative infinity. And then, so for our second one, as x approaches negative infinity, this one we can also kind of cheat. We can just plug in a very small number, like a negative 1,000 or something, and then if we get a very small number, then it'll be negative infinity. If we get a very large number, it'll be positive infinity. So let's do that. Let's do negative 1,000. Negative 1,000 cubed plus 1 over negative 1,000 squared minus 1,000, something like that. That ends up becoming, again, you don't have to solve the entire thing, just figure out what's positive, what's negative. So looks like the top will be negative a billion, so that'll be negative on the top. On the bottom is a million minus 1,000, which is positive. So that ends up being a very negative number. So we know that it'll be the limit will approach something negative, something like that. So anything that is positive, we know is wrong. So my pen just stopped working. So anything that's positive will be wrong. So something like D, and looks like A is our answer here. Look at that. And it approaches negative infinity both times. All right, question 6. You have this limit, and it represents f prime of A, which is, a derivative of f, and then, on the value A. And it wants you to find the original function and A, so that when you do this limit on it, it looks like this. It goes back to that, which looks suspiciously similar to that manual limit derivative that you've learned. The f of x plus h minus f of x all over h, or the limit for all that. So limit of h approaches 0 of that. So again, you just for each of these f of x's, or f of x plus h, f of x, you plug in these f of x's and the a value for x, and whichever one gets you back to this will be the right answer. So I actually went and looked at the solutions for this problem, and they literally just expect you to brute force this one. Like literally try each one of these and see if it gets you back to this. So that's what we're gonna do here. I have no idea how you actually go about finding this problem. I know sometimes you can just try just a simple f of x, like plug in a into its f of x and see if you get 1, but I think for all of these you end up getting 1, so I don't think you can do that. So let's try the first method. Let's just do the f of x's and a's for the whole thing, see where that gets us. Alright, so let's do the first one, cosine of x squared and a equals 1. So that becomes, we're looking back at this one here, that becomes, so f of x plus h, that's cosine of x plus h squared, and then, oh yeah, and then instead of x, it's a, which is 1, so that, and then minus f of x again, which is cosine of a squared, which is 1, and 1 squared is 1, and cosine of 1 is still 1, so that's just minus 1. That's what I was saying earlier, where all of these functions and all of these a values will yield 1, so we kind of know we're on the right track. And then all over h, I'm actually just going to omit that because it'll be the same every time. I'll include it for now. I can't make up my damn mind. And basically, does this look like that at all? No, not really. There's this extra 1 in here. But there is the squared here. This square was that square. So we're kind of getting a feeling that the right answer will have the cosine x squared and not just cosine x's like in B and C. So we're kind of feeling that out. And wouldn't it be really nice if this 1 wasn't here and it was just, if it was 0 and if it was just h squared, because if you do that, that actually is perfect. It looks exactly like the original one. So in a case like that where x equals 0, a would equal 0, because that would end up being cosine of x plus h, where x is a and a is 0, so that's just cosine of h squared. Or let me write this whole thing out. I'm going to get a little easier. Cosine of x plus h, where x is a and a is 0, which is that, plus h squared minus cosine of 0 squared, cosine of x squared, x is a is 0, all over h, and this just becomes, well, 0 plus h is just h, and then it's h squared, so cosine of h squared minus cosine of 0, if we have a circle, and we go all the way around, that just gives it back here, and that is 1. So 1 over h, that looks exactly like that, so I know that f of x must be cosine x squared and a equals 0, which is D. Yeah, D. So there you go. I again, I looked it up. I have no idea how you'd, you know, actually solve it like a, a mathematician, instead of just plugging in all of these and see which one works. But yeah, this one worked for us. So hopefully these kind of you'll have these sometimes where these limit questions. Uh, Hopefully all the ones that you will get are sort of this level of difficulty, because if you're um, given something complicated, yeah, I don't know how to do that one. So okay, I went and did this entire problem and nailed it, except that I forgot. I changed a plus to a minus right at the beginning and got a slightly wrong answer, so I have to do this again. Number 7, it is literally just a solve for x problem. And you'll see we've got ln's in here, so we'll be using our properties of logarithms. I think the best first step for this one is this one property where if you have two logs that are being subtracted, that ends up equaling, you can put the two logs together, and that's log of a over b, just like that. So that's what we have here. We have ln minus ln, so we stick them together, so that's just ln of the first part, x plus 1. That was what I did, by the way. I changed this to x minus 1 for whatever reason, over the second part, which is just x equals 1. So that condenses it all into one logarithm, and that makes it really easy to get rid of it, because we can use another trick that we learned, where if you just take the base of the log, ln is just log base e, stick it down there, so it becomes e to the power of everything that you had before. Do it on both sides so it's equivalent. This just cancels out that e to the ln, and you're just left with what was inside. So that's x plus 1 over x equals e to the 1, which is just e. Okay, and then I think here you just, we're going to divide these separately. So this is x over x plus 1 over x. So x over x is just 1. I don't need to write that out. And then plus 1 over x equals e. And then we'll do a little rearranging to get this 1 over x all by itself. Add it to that side, subtract e. Oh, wait, that's the plus. I almost did it again and would have gotten the same wrong answer. That is a plus. So we just subtract 1 for both sides to get rid of the 1. So that's 1 over x equals e minus 1. And then we just have 1 over x on that side, so we flip everything. So it becomes x over 1, which is just 1, and then 1 over e minus 1. There, that's the actual right answer, which is B. Yeah, okay. I got it right this time, thank God. Hopefully you don't make that many, switching pluses and minuses mistakes on your tests. I know I still do after 4 semesters of Purdue math. guess it kind of messed up my brain a little bit, but it'll definitely still happen to you if you do that. So don't worry. I need a break. All right, question 8. It gives you a graph of some function, and it wants you to find the graph of its derivative. So it's just testing you how well you know the relationships between a function and its derivative, what they mean, and how it looks visually, graphically. So uh, I think it'd be easy to first split it into 3 parts, where all these breaks are, and then just treat it as 3 separate functions. So I'll do 1, 2, 3. So function 1, this is just a straight line going up. It's linear, so we know that the degree of its function will just be 1. It'll be like f of x equals, some constant plus another constant, whatever it is. But it won't be, squared or cubed or whatever, since it's just a straight line. And we know that when we have uh, a standalone x and we take its derivative, it just, that 1, you take it out and then power drops to 0 and it gets rid of itself. So whatever the derivative is, it just ends up being a constant, which is just a straight line. So for this first part, it just needs to be a straight line, and it it looks like every single function has a straight line at the beginning. So that's good and bad. We know we're on the right track, but also we didn't narrow down any of our answer choices. So looks like oh, there we go. It looks like function number 2 will uh, narrow our sights a little bit on which one is the right answer. So it looks like the slope is going down, and it's going down, faster and faster. So we know that the graph, if we have our axes, let me put arrows on them so we know that those are the axes and not the function itself. We know that whatever the graph of the derivative is, it will have to be down here. It'll have to be in the bottom half because it is negative. The slope is negative for all of it. So we can actually just cross off a couple answer choices, whatever, like this part here for all of them, whichever ones have any portion of it in the top half, we can cross them out. So B, C, and E. This one's like partial for whatever reason. So we know it's either A or D, and they are both the same here, so we know can't do anything else with function number 2. So we'll go on to function number 3, which is just a straight line, which means that it's some function where it's literally just a constant. So we know that, and if you take a derivative of just whatever constant, that just ends up being 0. So it'll be a straight line right on the origin. So A, and you'll see with D, it's a straight line, but it's not on the origin. It's 1. And if you do the antiderivative of that, so if you go back to that one, that would end up giving you a straight line pointing up, which isn't true at all. We have a straight line going straight. So A is the correct answer here. All right, question 9. Compute the limit of this as x approaches -1 from the right side of that. So first thing we do for these is we literally just plug in -1, and if it all works out, we don't have like a divide by 0 or anything, then we're done. So, well, you can kind of tell that won't work though, because if we plug in -1 here, that'll be -1 plus 1, which is 0, and then 0 times 0 is 0, and or 1 times 0 is 0. So can't divide by 0, so that didn't work, unfortunately. So let's still evaluate this whole thing and see if we get like a 0 over 0, see if we need to do L'Hopital's rule. So that becomes, plug in -1, that's -1 minus 4 over -1 squared, -1 plus 1, which equals, okay, -5 over -1 squared is just 1, and we're multiplying, so we can ignore it, and then 0, -1 plus 1. So we don't have to do any L'Hopital's, and our limit is already sorta figured out. It's uh, negative infinity in this case. So you want to circle D right away, right? Oh, hold on. It is specifying that it needs to be -1 from the right side. So we need to figure out, like, it could be a function where, oh, what the heck happened to my pen? Let's shake it a little bit. There we go. It could, where was I? So, okay, left and right sidedness. It could be a function where it's like this, and we're asked to find the limit of that, where from the right side it's positive infinity, and from the left side it's negative infinity. So let's just check that out using our number line trick. So let's make a number line, and then the middle will be our limit. We're trying to find -1. And let's just plug in two values that are right around it. So let's do, um, well, let's not do 2 and 0 because 0 will just make it undefined again. So let's do -1/2 to start. Uh, yeah, so let's plug that in. So that's -1/2 minus 4 over -1/2 squared times -1/2 plus 1. And remember, you don't need to fully calculate all this. We're just trying to figure out the sign, like the ending sign of all this. So uh, let's do that. This ends up being still negative on the top, and then this is positive, and this would be also positive, just a half. So positive on the bottom, so that is negative. Anything negative divided by anything positive is still negative. So we know that this is all negative on this side. And on the right side, let's do, wait, I messed this up. Hang on a sec. -1/2 would be on the right. It's a bigger number, so there we go. Hopefully you guys weren't screaming at me too hard while I was doing that. Okay. Wow. I may need some water. Uh, and on the other side, let's do -2. Yeah, that'll work out. That'll still give us a real answer. So, okay. Come on, pen. Stop crapping out on me. There we go. Erase. All right, -2 minus 4 over -2 squared, -2 plus 1. Remember, we're just looking for the signage. Don't need to calculate everything. Negative minus negative is still negative over a positive times uh, a negative, which is negative, and a negative divided by a negative is a positive. So on the right side is all positive. We actually could have stopped a little bit ago, but since we're coming at it from the right side, which is this direction, since we found it's all negatives here, that means our answer will also be negative. So we have our, it's better to say we found our absolute value here at infinity, and on the front of it we just stick whatever sign we found, which is negative. So it ends up being negative infinity. So turns out E was the right answer all along. We just need to double check if it was one of those special two-sided limits where it's two different limits depending on what side you come from. So good thing we clarified that. Some problems, it'll end up being the opposite sign. So, not in this case though. It's still E, still negative infinity. All right, question 10. It's just a limit question, but it's asking for a slightly weird answer. It's just whatever answer you get, which interval is it in? So if it ends up being like 3/2, that's not a good example actually, unless these are negative. It ends up being -3/2, then it would be B. It's between -2 and -1. So that's all it's asking here. And you actually, this limit is not too complicated. It's just a basic sort of simplifying kind of problem. Um, you'll see what I mean. So like the denominator here, that can just be rewritten as x, let's see, -2 and x plus, or x minus x plus 2, x minus 3. There we go. That will end up getting back to the original polynomial. So that's x minus 3. You'll see these cancel. This ends up becoming 1 over x plus 2. And now we're in a state where we can just straight up plug in 3 here, which is 1 over 3 plus 2, which equals 1/5. And 1/5 is between 0 and 1. D. There we go. All right, question 11. We are almost done. You have a graph, which I'll graph out later, and then it's moved horizontally 3 units to the right. So 3 units to the right. And then reflected across the x-axis. So the x-axis is this, the horizontal axis, and it's just flipping it. So if the graph looked like this, afterwards it'll look like that because it's flipped across the axis. It's a little hard to visualize on a 2D drawing like this, but I hope you are picking up what I am putting down. So we start with what it asks first. So moving 3 units to the right horizontally. Whenever we are operating horizontally, you always operate on the x itself. So if we had if we wanted to move it up 3 units, it would be on the outside 2 to the power of x and then plus 3. But we're doing horizontal, so we do it specifically on the x. And also, whenever you are operating horizontally, you flip the sign of whatever you're doing. So this ends up becoming 2 to the x minus 3. And then we're reflecting across the x-axis. And when you see x, it wants you to think, horizontal. Same kind of deal. We're operating on the x. But that is not quite the case. So like if you visualize it. When what I just erased, if you have it being reflected like that, you figure out whatever the answer is. You plug in x and you get a y value. You just want to make it negative, so whatever is here, right? So in our case, we just figure out whatever our answer is and then negative it. That's how you flip it across the x-axis. If we wanted to flip it across the y-axis, I believe you would just make it negative there. You're operating horizontally in that case. But we're sort of flipping it vertically, so that's why we do it out there. And then that's it. That's the only operations I want us to do on that, which is C. There you go. All right, question 12. We did it. These exams are from a few years ago, but hopefully your exams are still 12 questions long. If they asked you to do any more, I would feel bad for you because that is a lot of questions to do in 60 minutes. So, anyways, so you have some function f of x that we don't know, but we know it is between two other functions, x plus 1 and e of x, and it asks us a couple statements about it. So this would be very good to graph out. So let's make some axes here. Let's make it a pretty big graph so we have room to work with. So let's do these two functions first. X plus 1, that touches at there, which is 1 and negative 1, and it's a big straight line, right? And then e of x, I believe that would end up looking like that there. And then, would it touch? Yeah, actually, I graphed this on a Desmo, so I'll show you what that looked like. Probably better than my drawing anyways. Okay, it touches right there, and then it goes off to the left on that axis. Okay, cool. Let's work with that. It touches there, and then goes off to the on the x-axis. Okay, cool. So if this is x minus 1 and this is e of x, that means that f of x is greater than x minus 1, so it's above for all of this. and it's less than e to the x, so it's below all of this, right? So f of x for every single value will be between. It'll be right there for all of it. You'll notice it kind of got like pinched right here. It might ask us something about that, right? So the shaded area is the values of f of x, could be in, right? And then which of the following are true? So f of x is continuous at x equals 0. Uh, should be, I believe, because it's just, some line going right through there. It's not, uh, the only the only thing we know about this point is uh, it must equal 1 at that point, but still continuous, still works out. So I believe that one is true. Limit as x approaches infinity is infinity. That is true because the minimum, which is x minus 1, also goes off to infinity. So that means that f of x must also go off to infinity. We'll actually see our answer is A, but let's rule out the other two as well. So as x approaches negative infinity, f of x also approaches negative infinity. Not necessarily true because so we're working the opposite here. The maximum, which is e of x, that does not go off to negative infinity as well. That goes off until 0. So f of x, the limit as x approaches negative infinity of f of x could also be 0, or it could be 2 or 10 or a million or anything other than negative infinity. It could be anything else. So not that. And then, okay, we just proved kind of the same thing. Limit as x approaches negative infinity of f of x equals 0. Also could be anything because the minimum x minus 1 goes off to negative infinity, so f of x could as well, but we don't know. These two are saying, yes, it absolutely will. But we don't know. We don't have enough info. So we say no for that one too. We see that A is true. It's 1 and 2 there. So there you go. All done with an entire exam. Feels good.